let me do just a quick review about these types of problems. Remember that we've got 3 doors to look behind for energy. We've got a force times a distance, right? So work is energy. Something could be on top of a hill, so there's mgh. It could be moving, 1 FmV squared. So for example, this car on top of this hill, it is both on top of a hill and moving at the same time. Can you have both energies? Yeah. What makes me sad is that there's no mention of somebody pushing the car down the hill, giving it a push from this point, in which case we'd have all 3, right? Okay. And then that goes or becomes, and this could be a force times a distance, and this is like something that slows you down. All these things on the right side are where the energy goes, right? It could go up a hill or be at a different height, and it could also be moving at the end. Guys, can I interrupt? Okay, so this is basically it. So the trick is to read these problems and just try to divine what is happening there. Now, almost all of them you can look at a picture and you've got a before and an after. Like here it's going to be the top of the hill versus the bottom of the hill. And it's really pretty simple. It either is at a height or it's not at a height. It either is moving or it's not moving, right? All of those are pretty simple. Force gets to be just a little bit tricky. And so what I'm going to do to help you out here is just say that this force here is left side forces are forces that speed you up, right? Okay, so this makes sense in terms of like where does the energy come from? Well, it's a force that pushed us, right? Okay, and then right side forces tend to be forces that slow you. So this is like the puddle that we went through in the example problem we did. Air friction, brakes, the car's brakes, stuff like that, right? I think you solved a problem like that. So, yeah, there we go. So it's all you do is you read this formula. What do we have at the top of the hill? Potential and kinetic. At the bottom we have only kinetic. So set them equal to each other. See if you can solve for the velocity at the bottom. When you get the answer, help your neighbors out, because this is really hard for some people to figure out. The math is hard, and yeah, you got it. Yeah, you got it. I don't get 49 as the last 2 digits. I'm worried. The distance, 2.15 is your height, and that's the only distance you need. We don't care what the distance is between them because there's no friction.
So your distance is your height?
Height, yeah, h is your height. And there's no force times distance. There's none of this. Yeah, you got it, I think. So this is not a factor on either side, right? What you've got is mgh plus 1 FmV squared turning into 1 FmV squared. At the bottom of the hill, you don't have any, there's no mention of any force slowing you down. There's no potential, it's just kinetic. Yeah? That's why you're going so fast. Yeah? Yeah? Just try it. Add Doggle Hunt.
Hold on.
What's that first digit?
8.
How is that an 8?
It isn't.
What?
It was in my mind.
It looks like it doesn't know what team it's on. That's right.
Yep.
That's right. There you go. Now it looks like an 8. Yep.
I'm right. That's wrong. I'm superior.
Yeah.
I'm just joking.
I'm not getting that. That's like really fast. Knock, knock.
Who's that?
Atch.
Add
Bless you. Knock, knock.
Who's there?
Kirch. Bless you. I've already done that joke, haven't I?
So Pete and repeat were on a boat. Pete jumps out, who's left on the boat.
Repeat.
So Pete and repeat
I like that one. That's in the same category, isn't it? It's a joke on the person. I've got a good one. Here, start the knock knock joke. Who's there? See, that's the joke. He doesn't even know who's there.
So Pete and repeat were on a boat. So Pete
Huh?
jumps up and goes, who's left on the boat?
I'm gonna do the mathematics. This is higher mathematics.
So Pete,
I'm gonna go 15 times.
Pete jumps out the boat, who's left on the boat? Hey, is this right? Pete, and then I'll be like, Pete, repeat. Yeah. I had to tell you that for like an hour. It's like, I don't get it. Just like, over and over.
So here's what the equation looks like. Holy cow. There you go. And now you've got to do math. So, are you using those to erase your whiteboards? Do you suppose that I don't have enough Kleenex to give them out 180 a day? Or- Okay, I did this whole left side in one swell foop, and I got 568.35. So now I'm going to divide this by 0.5 divided by. I'm going to square root both sides. Yeah? There you go.
Wait. Should the it's 5.8 squared, not the whole thing squared and the rest.
Mm-hmm. That's going to help a lot.
Yeah, that threw me off.
Math is tricky like that. If you don't do every single thing exactly right, you get the wrong answer.
What is it then? Wait, why am I still getting 568? Oh. Oh. I thought it was 7.5 b, not b squared, so I was like, what a math.
Hey, why did the pony have a hard time talking?
Because
He was a little hoarse. Oh no, not this one again. There's another one with lower.
Well, you asked. Yeah, you were just like, what's the
Yeah, I probably have to turn off the camera to tell that one. How are we doing on this first whiteboard problem? Are we done? Are we working on it? Are we anybody still working on it?
are we working hard or
Sort of. Do you want a better calculator than the one you have? That might help you.
That's the 3 words that guy can say. Program, games, and research.
He whispered.